Welcome to Silver Knight PCs. We got a 3090 Kingpin in today that we're going to be doing a copper shim mod, doing some maintenance. This card has been in the pits of mining hell for a few years, and then the customer purchased it secondhand, and we're going to go ahead and tear the whole thing down, make sure we're not going to have any problems with it. Apparently, it might have been liquid metalled previously, which can get messy if it's not done properly, and we're exhibiting a few weird memory problems in terms of overclocking, which is not too unusual for 3090s because the 3090 in general had not the best cooling on the backplate. We are going to be swapping out all of the thermal pads that are on the backside here and replacing them with these copper shims from coolmygpu.com. They make a fantastic kit for the hybrid series EVGA cards to be able to switch out the thermal interface that's used and then replace it with just straight thermal paste and copper. Now, thermal pads are great for filling space, but if we can increase the transfer rate from the memory to the backplate, we'll lower temperature significantly, and then at that point we can overclock it higher, which is the goal of this customer specifically. I think he's in a grudge match on 3D Mark that he's trying to settle. So the one advantage of using liquid metal on a Kingpin is that most of the heatsink is copper. If I'm not mistaken, the radiator is as well. I've got to, fact check that, but the part that's going to be touching liquid metal is going to be all copper, which is important because unlike normal thermal paste, which does not react or have any weird conductivity problems, the liquid metal is primarily gallium, and gallium reacts negatively with aluminum. If you leave it sitting on top of a aluminum can for too long, for example, or an aluminum heatsink, it'll start quickly corroding and then bubbling up and just deteriorating rapidly within a few days. So that's going to be the project today. We got to figure out what problems are with the card, what are the previous modifications, see if we can service the card correctly, and then install this kit. We're also going to be using conductor knot from Thermal Grizzly, Arctic MX6, which is the latest thermal paste from Arctic that they just launched, replacing the now discontinued MX5. There was some weird separation issues with MX5. We never really experienced it, but some people did online, and so Arctic in their wisdom decided to pull that product offline. And then we are using thermal pads for the power delivery. There are parts of this card that are not going to be getting the copper shim treatment. They just don't get hot enough to justify something like that. So those areas will fill in with a high performance thermal pad, and we should have some pretty good results with it. We do also have this pretty cool 3D printed GPU stand that we're going to start offering soon for folks. So keep an eye out on our website and we'll have those available soon. So let's go ahead and step into the teardown. All right, first things first, we need to go ahead and start getting this water cooler off. Now, Kingpin cards historically haven't been the hardest to work on. They're by no means the easiest. Any kind of water cooler on a video card is always going to be difficult, just because you have just so much added complexity, and then you also have reinforcement points here, and other spaces. So this little screen here just displays information like wattage, voltage. It's just a little LCD display that folds up. It's pretty cool, actually. And then the way it connects to the PCB, if I'm not mistaken, is the screws here via contact pad. It doesn't use wires, but at least we did one of these previously, and I don't remember it using any wires. So let's see here. This comes off. Oh, it does use a wire. Okay, maybe it's the 3090 Ti that's a contact pad, but yeah, it just uses a little cable, plugs right into there. Not too bad. Really easy to remove. And I've never got a Kingpin brand new, not the 3090 specifically, so I've always got them secondhand. It might be that this is an optional thing, and they swap these out with different parts. I know on the Hydro Copper card it looks a little different. So let's go ahead and get the rest of these screws out. All right, so backplate is coming off now. Let's see if we can desuction this off. Strange. Feels like something's holding it still. Okay, so there is a pad here in the corner, located right here, that feels like the backplate is still suctioned on pretty heavily. Okay, these look like the stock thermal pads. These have not been swapped out. Yeah, those are the original thermal pads. Let's take a caliper and measure real quick. They all look like they're the same height. It might be that the ones in the very middle are ever so slightly different. Let's see here. There's a little compression. Two millimeters. So all the backplate pads are 2, which isn't going to be that big of a deal because we're going to be swapping it all for copper anyway and replacing it with thermal paste. The way these work is you put thermal paste on both sides, and essentially it'll touch the areas that will be transferring heat, and then the thermal paste will naturally have a higher conductivity rating than thermal pads do. This is an example of one of the plates. I don't know if this is for this side or the other side. We'll check that in a second. But it'll sit something like that with thermal paste on both sides of the GPU to help transfer that heat over. All right, let's go ahead and unscrew the rest of the screws. At the bare minimum, the memory has never been touched on the back side, which explains why the memory overclocking isn't that good. Don't get me wrong, EVGA builds a beautiful card, but the 3090 inherently was somewhat flawed with the way that the thermal design was done for the backside memory. The 3090 Ti solved a lot of those problems with having all the memory on one side. So if you were to tear down a 3090 Ti Kingpin, none of this memory that you see here would be on this side. It would be on the other side of the PCB, and it's just basically double density memory. I think that was one of the innovations of the 3090 Ti. This seems like a space pad, like meaning just to help create adequate spacing. It's also strange that none of this componentry has a thermal pad on it, considering what this card is meant to do. And there's not a lot of airflow going through here. It just seems like it would get hot for no reason. So we'll see if we can put some pads there too, just to help drop temperatures a little more. All right, so now the cover comes off. Move these copper shims out of the way. Boom, boom. Sweet. Shroud is off. And we're almost at the PCB. This thing is pretty beautiful. It really went all out with all the copper. It's really nice. I like the finish. All right, so one thing to note, this is a legacy Kingpin. From my understanding, it's one of the first production run 3090 Kingpins. I'm sure there's probably a serial number on here that we can reference. Now, one of the legends among the Kingpin community, and I'm sure some people in the comments can help clarify, is that on the GPU die itself, if Vince worked on it, then it has a number scribbled on it with Sharpie. If it does, then that's pretty cool. Some people theorize it's ASIC quality, I should say, between 0 and 100 or 1 and 100. And I can't remember if the higher end numbers are the better ASIC or if it's the lower end numbers that are the better ASIC quality. But I'm sure Vince bins tons of these chips just to see which ones he's gonna keep for his own, overclocking, which is extremely convenient for him being a world-class overclocker. So we're gonna go ahead and remove the AIO next, so that way we can kind of get the water cooling tubing out of the way. Make things a little easier to work on the card. Now, this little piece here comes off fairly easily. It just has 2 screws that hold it in place. And then this wire runs up here to control the fans. And then this wire plugs into the board. Now that might be a little hard to get to, so we need to kind of take it one step at a time. Okay, so the easiest way to take this apart is to remove this. Yep, this thing's been liquid metaled all right. The application doesn't look terrible. It doesn't look great either. It's kind of just in between. I don't know why this was done. Okay, so they're trying to transfer the heat from this plate to the AIO, but the problem is I can only imagine that the cold plate itself is only the size of this right here. So if you're trying to cool the memory with this, I don't know how effective it is, but I'm sure Vince and his team knew what they were doing when they designed it this way. So let's get this thing off and get a better look at the die and clean it up a little bit. All right, another shocking discovery. Not really, this is pretty standard. This is original from the factory. So the GPU die itself being liquid metal modded is aftermarket. Someone definitely did that. We'll see about the thermal pads. I'm sure the thermal pads are probably the stock ones again, but they used, it's kind of like thermal paste, but it's a little thicker and goopier. Has thermal putty on the GPU VRMs. Now, I have never really used this stuff to know the conductivity of it. I'm sure it does a great job, and there's probably a reason they use this instead of thermal pads. But the thermal pads we're using are gonna be really high in terms of conductivity, so there's really no reason for us not to use them. All right, we'll move that out of the way. We gotta get that cleaned up here in a minute. And let's get the heat plate off. Let's see. Same thing, thermal putty stock from the factory. These little copper heat sinks are nice. All right, so let's see if we can get this thing off now. Oh, there we go. Yep, those are the stock memory pads. That was never changed. And I don't see any Sharpie. So I can only assume that this is one that Vince did not work on. From my understanding, the ones that are out there, they'll have like a little number in black Sharpie written, either here or here somewhere along the edge of this silver plate. And then I don't know if these blue and green dots mean anything. Maybe they simplified the process as time went on. They made a more simplified way to number cards. Maybe that means something. So if anybody out there knows, go ahead and sound off in the comments. What a beautiful PCB. I mean, all gold. And you know, I've asked MSI about it. I was like, you know, how hard would it be for you guys to make a all gold card? You know, maybe like a special edition, something like that. They have, you know, golden lucky dragon or whatever. And they basically said it's not hard to do. It's just more expensive. And I guess you know, Vince with EVGA, they had built a reputation as to having these types of cards built, and the way that the performance was on them. I mean, if you look at Firestrike and you know, 3D Mark in general, it's not always these cards on top. So the gold PCB doesn't make a massive difference. I'm sure on on a thermal conductivity thing, it's much better. But in terms of what the GPU is capable of, it probably matters a lot more what the power delivery looks like. And maybe it holds up longer. I mean, I've never seen a defective Kingpin yet. Maybe, you know, I'm sure someone out there has had a bad one, but every time I've ever tested one, they always worked. Ooh, found a little something. So this port here on the end, I was looking at it earlier when we in-processed the card. I don't know how visible it is, but this port here is loose compared to these other ports. You can see that. It's a little uneven compared to these two other. These are flush, and this one isn't. And you can see on the back plate here, the screw hole here is messed up, which it's not really a screw hole, it's just a clip. So I'm gonna see if I can push that back into place and then spread that clip back in. So if you notice here, the port here is looser than these other two ports. These two are flush to the PCB. This one's kind of sticking up a little bit, not completely flush. And if you were to look at it from the side profile, you could see it right there, versus these two are completely flush. All right. So normally, if we were doing this as a like a repair job for a customer, if this was like not making a good connection or something like that, we would just take the port off, like completely desolder it and put a new one on. But this is such a minor thing, like it's just a thing where we need to probably just straighten out that little clip and push it down some more, and it should fit fine. And customers shouldn't have any problems with it. It's making a good connection still. It's just a matter of the weird spacing that's occurred there, probably just from PCIe connectors being pushed into it repeatedly. Okay, so that's done, that's done. This is a problem. It's solid, and I'm probably gonna have to either sand or shave this down a little bit for it to work properly. It's not a perfectly flat surface by any means. Let's see if we can get some more rubbing alcohol on it. This is isopropyl 99% alcohol, and let's see if we can get it to soften up and come off. Let's go, come on. Getting something. It's not much. That raised surface right there especially is still very much solid. There we go, just get scrape it off. You know what? I might just have to do that. Just kind of rub it a little bit with a flathead screwdriver and get it off. Because the problem is we don't know what brand liquid metal was previously used. So it might be a situation where this is this is permanently damaged. It does look like it's sitting on top of it, so I might be able to just use a little sandpaper and lightly sand it flat. It's very much not ideal. Let's see. All right, and we're back. We've done a little bit of sanding on the AIO portion of the water cooler. The liquid metal was pretty pitted in the topmost layer of the copper, but we used a little bit of sandpaper, 800 grit, and we got it smooth enough to the touch where I find it acceptable. Liquid metal likes a little bit of a rough surface to be able to bond to, so that'll help in the long run. And I think at this point we're ready to install the copper plates. I got the thermal pads already arranged on the card in several areas. The thermal pads underneath this heatsink has already been replaced. And then I put a little bit of Kapton tape around the capacitors. We thought about it a little bit, and instead of using like Vaseline or nail polish, which are both fine in a pinch, or if you're doing some LN2 stuff, we felt like for the long term, just keeping a little bit of Kapton tape will help a lot. Just make sure that that liquid metal never gets on those capacitors. It won't necessarily kill the card usually. Usually it'll cause the card to short and then you need to clean it off to get it functional again. But there's long-term corrosive effects to having liquid metal touching solder directly. Gallium reacts to, I don't know what exactly in the solder, but it causes it to break apart. There used to be a really popular time when we used to put shunt mods on 1080 Ti's using liquid metal, and that time thankfully is past. It was to unlock more voltage and power delivery to the card. But yeah, so we're gonna go ahead and install the copper shim mod now and reassemble the rest of the card. We're gonna need a lot of thermal paste to make this happen. Like I said, we're using Arctic MX4. Sorry, MX6. MX4 is the older stuff. And a little too much isn't the end of the world. You're not going to damage anything. Having too much thermal paste, if anything, is just gonna give you a mess to clean up in case you have to do a reapplication. All right, so we'll go ahead and install the first layer of the copper shim mod. It's kind of like a sandwich that goes together and reassembles on the PCB. It kind of has thermal paste, copper shim, thermal paste, another copper shim, thermal paste, cooler. It's quite a bit. So we'll go ahead and get that installed. First layer going on. Boom. And I don't have the other heatsink installed yet. There we go. Got thermal paste coming out just a little bit on the sides, which is fine. We want to make sure there's an adequate amount of paste. Okay. Oop. Okay. And then this will go on afterwards because it's a lot easier to put the AIO on with this off and then run the cable to plug in the fan and pump assembly. So you don't need much liquid metal. It takes a very small amount. We're just gonna take this Q-tip that's included with it and kind of just spread it out. What we're looking to do is make a wet contact surface that's consistently wet across the whole GPU die. Alright, and one thing that a lot of people miss out on when they're doing this is they have to apply it on both surfaces. If you do not apply it on the other surface, you will have all kinds of problems where it will have hot spots for no apparent reason. And the reason why is because there's no liquid metal on the other surface.
Before a repair on the graphics card, the GPU core temp was idling at 26 degrees and maxed out at 65 degrees. The memory was hitting 80 degrees plus consistently on stress tests. After a little sanding with sandpaper and water at 800 grit, we were able to reapply the new Conductonaut liquid metal. Our temperatures improved to 19 degrees Celsius idle and 50 degrees max core temp at stock settings. The memory maxed out at 68C. As you can see, temperatures improved across the board. With some modification work, you too can restore even an improperly modified card and maybe help you win your next benchmark grudge match. If you need help with your own GPU, stop by, email us, or call us. If you like this type of content, please like and subscribe and comment below. It really helps us figure out what type of content you guys are looking for.